Welcome to another video on completing the square. Now, so far in this series of videos, we've just looked at factorising quadratic expressions by using this technique of completing the square. In this video, we're going to go a step further and look at solving some quadratic equations using this technique. So if we have a look at this quadratic equation here, okay, and we want to solve this quadratic equation, first thing to do is factorise. So are there two numbers that multiply together to give negative 10 and add together to give positive 4? So let's work that out. So we've got negative 10 and positive 1. We've got positive 10 and negative 1. We've got negative 5 and positive 2. And we've also got positive 5 and negative 2. Now, which one of these combinations gives us positive 3 when we sum them together? Well, it looks like this bottom one here would work. 5 minus 2 does give us positive 3, and 5 times negative 2 does give us negative 10. So actually, we can factor this quite nicely. So this will just factor to x plus 5, x minus 2, and then that equals 0. So then we can just solve this equation. We've got two solutions. X equals negative 5 will be one solution, and x equals positive 2 will be our other solution, because whenever we input these numbers into this bracket, negative 5 plus 5 is 0, 0 times anything is 0, and also 2 subtract 2 is 0, and whatever we've got in here, doesn't matter what we've got here, if we're timesing by 0, we'll always get 0. So we found our two solutions. So that's quite nice, but what would happen if we had a quadratic equation that didn't factor nicely? So let's say we've got the equation. Let's say we've got x squared plus 4x minus 18 equals 0. Okay, so again, let's think about two numbers. Are there two numbers that multiply together to give us negative 18 and add together to give us 4? Well, no, there aren't, because the only two numbers are 1 and 18 or 2 and 9, and no combination of 1 and 18 or 2 and 9 will give us 4. So we can't factorise it simply by using this method. So we're going to have to complete the square. So when we're completing the square, we just focus on these numbers here. This 18 doesn't really have anything to do with when we're completing the square. So what I'm going to do is I'm going to get rid of that negative 18. I'm going to move it to this side of the equation. So in order to get rid of it, I'm just going to add 18 to both sides. Okay, I'm not interested in this. I'm only interested in this bit here. So I'm going to get rid of that. So what I'm left with is x squared plus 4x on the left hand side, because that cancels, and on the right hand side I'm just left with 18. Okay, now we're going to complete the square. So if I rewrite this, x squared plus 4x, and I leave a space so I can complete the square, and then that equals 18. So in order to complete the square, I half the coefficient in front of x and then square it. Half of 4 is 2, 2 squared is 4, so I need to add 4, and now I have made a perfect square. But remember, whatever I do to the left hand side, because we've now got an equation, I have to do the same to the right hand side, so I need to add 4 to the right hand side. So in the previous two videos, when we were just looking at the expressions, to complete the square, if I added 4, I needed to subtract 4, but now we've got an equation slightly different. Because we've got an equation, whatever I do to one side of the equation, I have to do the same to the other side. So if I add 4 to the left, I have to add 4 to the right. Okay, now we can factorise this. So this factorises nicely now. So this is x plus 2 squared. 2 times 2 is 4, 2 plus 2 is 4. And then that equals 18 plus 4 gives us 22. So we have completed the square. So that's the first step. Now we just need to solve the equation. And to solve the equation, we can just use what we know from our balancing method in algebra. So at the moment we're squaring. So to get rid of that square, we just square root. So we square root the left hand side, square root the right hand side. So on the left hand side, we're just left with x plus 2. And on the right hand side, you might be tempted just to write the square root of 22. However, if we think about what's going on here, we're thinking about what two numbers multiply together to get 22. Now, if we use a nice example of, let's say, 9, and think about what two numbers multiply together to get 9, well, 3 is one option, because 3 times 3 is 9. But also, negative 3 is also a valid solution, because negative 3 times negative 3 is also 9. So whenever we take the square root, we have to make sure we write plus or minus in front of it. There are two solutions. There's the positive solution and the negative solution. Okay, it's really important we include that, because just like here we've got two solutions, here we're also going to have two solutions. Now the last step is just to isolate x, so let's subtract 2 from both sides. And we are left with x equals minus 2 plus or minus the square root of 22, and that is our solution. Okay, so we've got two solutions here. Now it might not immediately pop out to you, but this we could say, if we split the solutions up, we could say x equals minus 2 plus root 22. That's one solution. Or the other solution is x equals minus 2 minus the square root of 22, and that is our other solution. So just like before we had two solutions, here we've also got two solutions. So it's obviously a bit more involved here. The only thing different we had to do was we had to complete the square because we couldn't factorize it normally. Okay, but once we did complete the square, we just applied what we know about our balancing method in algebra, and then we just solved our equation. And this bit here is really important because we've got two solutions. Okay, let's do one more example. So let's just scroll down. So this time, let's say we've got the expression x squared, or the equation x squared plus 6x minus 11 equals 0. Okay, are there two numbers that multiply together to give negative 11 and add together to give 6? Well, no, because the only two numbers that multiply to give negative 11 are 1 and 11, with one of them being negative, and neither of those give us 6. So we need to complete the square. Now before I complete the square, let's just get rid of that 11. So if I add 11 to the left hand side and add 11 to the right hand side, I'm left with x squared plus 6x on the left hand side, and on the right hand side I'm left with 11. Now I can complete my square. So if I rewrite this, x squared plus 6x, and then I leave my space, and then that equals 11. Again, half the coefficient in front of x and then square it. Half of 6 is 3, 3 squared is 9, so I need to add on 9. And now I've got my perfect square, and I'm not done there. If I add 9 to the left hand side, what do I have to do to the right hand side? I need to add 9, so I need to add 9 to the right hand side as well. Okay, these two are equivalent. I can't just change the value, I need to make sure I keep the value the same. Okay, so now this factors nicely. This is just x plus 3 squared. 3 times 3 is 9, 3 plus 3 is 6. And on the right hand side, 11 plus 9 is 20. So now we've got a nice equation which we can just solve. So let's square root both sides. Square root the left, square root the right. We're left with x plus 3 on the left, and on the right, plus or minus the square root of 20. And again, do not forget the plus or minus. Really important. I'm going to keep harping on about it because there are two solutions. Okay, now our final step, we come to the end. If we subtract 3 from both sides to get x on its own, we are left with x equals negative 3 plus or minus the square root of 20, and that is our solution. So again, if you wanted to see the individually, we could say that that is x. One solution is x equals negative 3 plus root 20, and our other solution is x equals negative 3 minus root 20. So again, we've got two solutions. Okay, so just to summarize, in the first couple of lessons, we just looked at completing the square. So when we had a quadratic expression that we couldn't factorize normally, we completed the square. And now, once we've completed the square, we can now solve the quadratic equation. So using this method of completing the square, it allows us to solve any quadratic equation, and that's why it's so powerful. So I hope you enjoyed those videos and keep practicing.